Okay, so that was the backward bending labor supply. So now what we're going to discuss is this idea of, we looked at factor demand, we looked at factor supply, and what we're going to briefly talk about now is what are some things that determines factor demand. Okay, so basically shifts, what are the things that shifts factor demand. So the first thing that we're going to look at is this idea of product demand. Okay, so um, the demand for a factor, okay, let's say if we're talking about labor, okay, um, the demand for any factor or input, okay, is based on the demand for the product that these factors are going to make. So let's say if the product is shoes, okay, we don't really care, right? For we don't care for shoemakers in and for just for themselves, right? We care about shoemakers, or we hire shoemakers because there are demand for shoes that need to be made. So we don't hire shoemakers just for themselves. We hire shoemakers because there are demand for shoes. So for any kind of resource or factor or input, um, the demand for those inputs is based on the demand for the product. So we call that, this idea that the demand for the factor is based on the demand for the product, we call that derived demand. It means that it origins, or it is based on something else. Okay, so when if we're talking about, let's say, the market for shoes, okay, so this is let's see, I'm just gonna take you guys through this. It's easier to do. So let's say, we're looking at this idea of derived demand, so which is essentially just looking at this point, product demand, this number one. Okay, so it's the same idea. Product demand is the same as the derived demand. So what we're going to take a look at here is what happens in the product market, how that translates in the factor market. Okay, so let's say if we are talking about shoes, okay, shoes are the products that we're talking about. So in the factor market, we're talking about shoemakers. So in the market for the product, in the market for shoes, so this is the supply curve, this is the demand curve, this is the equilibrium price. Okay, so all the black, all the lines in black, all the supply curve and demand curve in black, those are the initial supply and demand curve before anything happens. And so this is the market, this is the farm. P star is the equilibrium price, Q star is the equilibrium quantity. For the farms, they're price takers, so the price they accept is the market price, and then the quantity is at the intersection of marginal cost and marginal revenue, correct? So this is the Q star. Okay, and on the factor side, this is not related in the sense that this W star is not coming from the product market. This W star is being determined in the factor market, the demand and supply. We're just here to see that the intersection of the demand for labor and supply for labor gives us the equilibrium or the profit maximizing quantity of labor to hire. So those are all the lines in black are the initial conditions before anything changed. Okay, so now let's say there was an increase in demand for shoes in the product market, right? So the shoe is a product, and there was an increase in demand for shoes. So what that does in the product market is that the price of shoes are increasing. So we go from P star to P2, and therefore the quantity of shoes also increased. Okay, we're over here. And on the farm side, because farms are price takers, they're also going to have to accept this price P2 as given. And what that does for them is that we know that their price is also equal to their marginal revenue. So they have a new marginal revenue and a new demand curve, which means that they have a new profit maximizing quantity at Q2. So why this is relevant in the factor market is this idea of the marginal revenue product of labor, which comes from the product, which is the product of marginal revenue times the marginal product of labor. So we discussed this not yesterday, but the not Tuesday, but the earlier on Thursday of last week. So the marginal revenue product of labor, which is also the demand for labor, so which is why we have the demand for labor is equal to marginal revenue product of labor. So when this is increasing in the product market, so the price that you can sell the product for is increasing, which automatically means that the marginal revenue product of labor is going to increase as well. So the demand curve for labor shifts to the right, and that comes from what changed in the product market. The change was the demand for shoes increased, so automatically there was an increase in demand for shoe workers. So what that literally translates to in the factor market is that even at the same wage W star, now we're going to be hiring more workers. So before, initially, the number of workers that were hired at this L star, and now we're just going to be hiring more workers and at this L2 level of workers. So the supply of labor didn't change, it was just the demand for labor changed, and that change came from the change in the product market. Okay. So this was a very elaborate way of showing how the product demand definitely increases the demand for a good. Okay, so the MRPL increased, and therefore demand for labor increased. And the same way for the second determinant of factor demand is the resource productivity. So really just the marginal product of because we're talking about labor here, and we're going to keep talking about labor. So if the marginal product of labor increases, remember that the demand for labor is equal to the marginal revenue product of labor, which is equal to the marginal revenue times the marginal product of labor. So first of all, when we talked about product demand, we saw that this thing was increasing, the marginal revenue was increasing. But now if there is an increase in resource productivity, which means that the same workers can now produce more output per hour, it means that the MPL is increasing. So if this thing increases, the demand for labor will increase as well. Okay, if MPL goes down, demand for labor will go down. Okay. And then the very last thing, determinant of factor demand, is price of other resources. So substitute resources and complementary resources. So a substitute for labor in production is capital. Okay, so farms, sometimes in production process, they can use either labor or capital to produce the same thing. So if you are if we're talking about a fast food business, let's say we can hire workers to create drinks for people, or like just to pour beverages for people. They can do that manually. We can hire workers to do that, or we can have a machine that will automatically pour beverages in cups based on computerized orders. So in that sense, workers and machines, they're substitute for each other. So okay, so what happens if the price of machines decrease? If the price of machines decrease, right, and they're substitute for each other, farms will start to use less labor. Okay, and if the price of machines increase, and because they're substitute for each other, farm will respond, or business will respond by hiring more laborers, right? So for substitute resources, if the price of machine is increasing, the demand for labor is increasing. And if the price of labor in machines go down, the demand for labor will go down as well. So for the substitute resources, the arrows, right, are moving in the same direction. For complements, right, it's when labor and capital are no longer competing with each other, but you actually have to, for some production processes, you actually need both of them to work together. You need one with the other. So one example of this would be like maybe ultrasound machines, right? So in order for if there is demand for ultrasound services, you can't use the ultrasound machines by themselves. They don't really do anything without a technician. So the technician and the machine sort of goes hand in hand. You can't have one without the other. So if the price of ultrasound machines were to go down, what would happen to the demand for ultrasound technicians? Would that go up or down? It would go up, right? Because if the price of the machine is going down, it is more affordable. It is more, you can buy more of those ultrasound machines, but you also need more of the workers to work those machines. So the demand for the technicians is also going to go up. And if the price, I'm sorry, this is going to be capital. So if the price of the machines were to go up, sorry?
No.
Did you have a question? I'm sorry.
No. Sorry.
Okay, sorry. And on the other converse situation, if the price of the machine were going up, you would respond by hiring less technicians as well. Okay. So those are the three determinants of factor demand or labor demand. This is just a concise summary table to that you can just come back to if you needed like a refresher on when labor demand increases and when labor demand decreases. Okay, so it's those four or three really. So this is the third one. This is 1, 2, and this is the third one. Three determinants. And then we're going to talk a little bit about this idea of we know that farms can use different inputs in their production process. So sometimes it's more beneficial to use labor, sometimes it's more beneficial to use capital. So how do they really know what combination of labor and what combination of capital to use if they're trying to minimize cost? Okay. And they want to minimize cost because this is what profit maximization really means, right? You can either increase revenue or you can decrease your cost in order to maximize your profit. So right now we're looking at the factor market. So of course factor prices, those are cost for farms. So we're going to take a look at how these farms can decide what combination of labor and capital they should hire if they're trying to minimize cost. And the rule for to minimize cost is something like this. So this should look very familiar from when we did consumer theory and we talked about utility maximization. Okay, so remember when we talked about utility maximization, a consumer was trying to decide, between two different goods, X and Y, and how much of each good they should buy if they're trying to maximize their utility. So when something like this, the marginal utility of dollar from X divided by the price of X, and the marginal utility of Y divided by the price of Y, we have to make them equal to each other under a certain budget constraint. So it's the same idea here that you want the marginal product of labor divided by the price of labor equal to the marginal product of capital divided by the price of capital. Okay, so think of the marginal product of labor as really just the output, and the price of labor as the dollar, right? And then same idea here, so output per dollar. So you want output per dollar from labor to equal the output per dollar from capital. You want, this thing like the bang per buck. You want the most impact for your money. Okay, so you're going to hire the input that is going to give you more bang per buck. Okay, if they're not equal to each other, right, the situation with something like this, or this way or that way. Let's say if the situation were like this, that they were not equal to each other, the output per dollar from labor was not equal to the output per dollar from capital. What that really means is that, for the first situation, we are assuming, so what do you guys have sort of a guess as to what this means? Like, what does that mean for a firm, this situation right here? So this situation means that you're getting more output per dollar you spend from hiring labor than you get from the output per dollar you spend on capital. So labor is giving you more output for the money that you spend, and capital is not giving you as much, I guess, output or impact for the same amount of money you're spending per dollar. Okay, so for every dollar, the marginal product of labor is higher than the marginal product of capital. So it makes sense if you are if you're trying to if you care about maximizing, or if you care about minimizing cost, okay, you will hire more labor because it gives you more bang per buck than capital. So you should increase your consumption, or you should hire more labor and you should hire less capital. And if you keep doing that, if you keep increasing more your hiring more labor, what will eventually happen is that the marginal product of labor will actually go down. And this happens because of something we talked about a long time ago, which is a diminishing marginal return to labor, which means that as we are hiring more and more labor, we're not increasing capital at the same time, right? We're decreasing capital. So these labors are going to get in each other's way, and they're just not going to be as productive as they can be. So the marginal product of labor starts going down, but the marginal product of capital starts going up. And this thing, one will keep going down and then the other will keep going up until we can reach this situation where they're equal to each other. But this is what we want. So this is the least cost rule. We want these two ratios to be equal to each other if we want to minimize cost. Okay, so let's take a look at this table right here. So we're gonna try to decide what is the least cost combination of resource to use for this particular producer. Okay, so this producer, he produces gadgets and he has $35 to spend. Okay, so of course he's working with a limited budget, and the machine costs $10 per hour and factory workers cost $5 per hour. So the question here is that what is the least cost combination of labor and capital he should hire? Okay, so what is going to be the least cost combination? So we know that for there to be the least cost combination of resource happens when the marginal product of labor divided by the price of labor is equal to the marginal product of capital divided by the price of capital. So we're going to have to find these two things, right? These two ratios. Okay. And we're going to have to find instances where they're equal to each other. And then we're going to try to find different combinations, right? Where not only that these two things are equal to each other, but also where we're spending all of our money. Okay, so remember, I hope this brings back some memory from when we did utility maximization. It's very similar to what we did back then. So here, labor inputs can range from 1, 2, 3, and 4. This is the marginal product of labor that we were given. We didn't have to calculate these numbers. This is capital, 1, 2, 3, 4 machines, and these are the marginal product of capital. So all we have to do now is just calculate the ratios for every single labor input. So we have the price of labor, which is 5 per hour, and we have the price of machines, which is 10 per hour. So all I'm going to do is I'm going to calculate these two ratios for every single one of these labor inputs. So 20 divided by 5, this is 4. This is 15 divided by 5, 3. 10 divided by 5 is 2. And then 5 divided by 5 is 1. And for this column, it's 30 divided by 10, which is 3. 22, 10, 1, and then 5 by 10 is, this is 1/2. Okay, so I'm done with finding the ratios. Okay, and now I'm gonna have to, so I calculated the ratios, so I'm done with calculating the ratios. Now I'm gonna have to find two, or instances where these ratios are equal to each other. So do you guys see any where they're equal to each other? Those in some numbers in those two columns where they're equal to each other.
3 and 3.
And there's one more.
2 and 2.
Good. So now all I'm going to do is I'm going to see which one of these combinations, right? I know that I have satisfied this condition, that I have found the ratios to be equal to each other. But now I also have to make sure that I have utilized my income, all of my income. So if I do this, we go with this ratio 3 and 3 for labor, it means that I have to hire 2 workers. And for capital, it means that I have to hire 1 machine. So I'm going to try to find how much that combination costs me. Does that use my budget or not? So for 2 workers, I'm going to hire, for this ratio 3 and 3, it's 2 workers times the price of workers, which 2 times 5, plus 1 machine times the price of machine. So this is only equal to $20. So using those 2 combinations of labor and capital, 2 and 1, I would only use $20 of my budget. Okay, but if I were to go with the other ratio, which is 2 and 2, that means I am going to use 3 labors, 3 times 5, and then I'm going to use 2 capital, 2 machines, so 2 times 10. So that actually gives me $35. So the optimal combination of labor and capital to use is 3 labor and 2 machines. Okay, so this is the least cost rule. If you were to minimize cost for your business, this is what you would do. Any question here?
No.
Okay, so then the very last thing we have to talk about is the imperfectly competitive labor market, which is monopsony. Okay, so this is similar to monopoly that we talked about in the product side. Monopoly was, there was only one seller in the market. Monopsony is when there is only one buyer in the market. And because we're talking about labor here, so we're going to assume that there is only one buyer of labor in the market. And they are so big that they're large enough to affect the wage rates. So they differ from the perfectly competitive labor market in this way. The perfectly competitive labor markets, they were wage takers. They didn't have any market power to influence the market wage. They just had to take the market wage as given. But the monopsony is a we call them wage setters. They can set the wage. And the labor supply curve for a monopsony is upward sloping. Remember, if you think about the perfectly competitive labor market, their labor supply curve was perfectly elastic. So perfectly competitive labor market, perfectly elastic labor supply curve. It was horizontal, but for them, for the monopsony, their labor supply curve is going to be upward sloping, which means that if they want to hire more workers, they have to increase wage. Okay, so this is how it looks like, right? So this is labor, this is wage, this is the supply curve. So if I want to hire more workers, go from L1 to L2, I have to increase the wage that I'm paying workers. And yeah, a perfectly competitive market, they could employ as many workers as they wanted at the market wage, but the monopsony can't do that. So for a monopsony, remember that the relation between labor and wage is this is the supply curve. Okay, so at zero, if you haven't employed anybody, of course, the hourly wage is 3. At the hourly wage of 4, one worker is willing and able to work. At the hourly wage of 5, 2 workers is willing and able to work. So this is the labor supply curve, right? What we see here is that the hourly wage is no longer a constant number as we saw with the perfectly competitive labor market. It is increasing as we hire more and more and more people, go from 1 to 2 to 3 to 4. We have to increase the wage that we are offering. Okay, so this is what we mean by them having an upward sloping labor supply curve. And the total factor cost is just the we're multiplying these two columns together. So how many numbers of workers we are hiring times the hourly wage per worker, that gives us the total factor cost. So in this case, because we're only using labor, it's just L times W. Okay. And the marginal factor cost, remember, it was the change in the total factor cost divided by the change in labor. So it's 4 minus 0 divided by 1, 10 minus 4 divided by 1. So 4, 6, 8, 10, and 12. So what's interesting about this is that the marginal factor cost is no longer equal to the wage. In perfect competition, or the perfectly competitive labor market, MFC, the marginal factor cost was equal to the wage rate, not in monopsony. As we see here, for the first unit of labor, the hourly wage is 4, but the marginal factor for the first unit of labor, it's the same. The hourly wage and the marginal factor costs are the same. But for the second unit of worker, the hourly wage is 5, but the marginal factor cost is 6. For the third worker, the hourly wage is 6, but the marginal factor cost is 8. Okay, so this line, this is rising faster than the supply curve. So MFC rises faster than the labor supply curve. Okay. All right. So this is what it looks like. Okay, there are two different graphs. I'm sorry, not two different graphs, but we have two different curves. So the supply of labor is this line. It is below the marginal factor cost. The marginal factor cost rises higher than the supply of labor. So the marginal factor cost curve looks like this. This is the supply of labor, and this is the demand for labor. Okay, and where the monopsony is going to, the profit maximizing quantity that they're going to hire, it's the same idea. The quantity of workers that they're going to hire is the same, which is MFCL, where these two things are equal to each other. Okay, so this is where this happens. So this is how many workers that they're going to hire, the monopsony, because this is where the marginal revenue product, this demand is equal to the marginal factor cost. Okay, but take a look at the wage that they're going to pay their worker. It is over here at WM. So what they do is they take a look at this quantity LM, okay, the quantity of laborers that they're going to hire, and they take this all the way until they can hit the supply curve. Okay, just like we did with monopoly. Remember, we took the we found the quantity that they're going to produce first, and then we found the price by finding where that quantity hits the demand curve. So here we find how many workers they're going to hire, which is this quantity LM, and from there we find what is the willingness, what is the minimum wage that the workers are going to be willing to accept. If I want to hire this many people, I have to pay them this quantity. But this is how much they're going to be willing to accept. So they don't have to pay them this high wage over here. They can get by paying them this low wage rate, which is where the LM intersects the supply curve. Okay. So what is interesting about monopsony is that it's very similar to monopoly, because if this were perfect competition, this is how much the perfectly competitive labor market would hire this many workers, but the monopoly hires a lower quantity of workers, and the wage that the perfectly competitive labor market would pay these workers would be right here. So the wage that they pay is also lower than the perfectly competitive labor market. So they pay lower wage and they hire less workers compared to the perfectly competitive labor market. So there is also a deadweight loss that happens, which is this triangle over here. So by moving away from this perfectly competitive labor market quantity, so by not hiring at LPC and by not paying this wage WPC, they essentially create this deadweight loss, the monopsony. Just like monopoly created a deadweight loss because they produced lower quantity and charged a higher price, the monopsony, they hire less workers, but they pay them a lower price than perfectly competitive labor market. Okay. Right. Do you guys have any questions? Anything that I that wasn't so clear about this, or that you didn't understand?
No.
No.